Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
I don't think that the sweet spot is the short-range trips. Market potential, once you can hit the range, once you get to that 100-plus mile range for a given flight, I think the market potential just explodes. So I think for these aircraft to become truly ubiquitous, you really do need that range. And before that, it's fine to enter the market with those shorter ranges. You're just not going to grow to your full potential.
Hey everybody, welcome back to The Vertical Space and a conversation with Damon Vander Lind, co-founder and CEO of Magpie Aviation, a company enabling long-range flights with zero emissions. So let's make it clear from the beginning, Damon and Magpie are offering a solution that is fresh and new. A lot of you will be fascinated by his vision, at the same time find reasons to challenge his assumptions, and you have to admire his bold approach to the market. He talks about how today's eVTOL vehicles are targeting shorter range missions, around 50 miles in good conditions, with a more limited value realization, and how he believes greater range, including under conditions that are less than optimal, is the sweet spot. Listen to Damon's views on the evolution of advanced air mobility, of electric aviation, and the use cases being addressed. Damon talks about how the industry needs solutions that address sustainability and carbon reduction, and that sustainability will become more essential as a requirement in the years to come. He challenges and gives his perspectives on some of the current solutions for sustainability, including sustainable aviation fuel, which many of the airlines are betting on today. There are those who will criticize some of today's eVTOL companies for overstating their impact on the environment. With Magpie and their promise for extended range, they have the opportunity to provide zero carbon flights to longer range trips. So he's all in on sustainability because customers will be paying a premium for the extended range, as well as some additional trade-offs. And Magpie is betting the greater value of sustainability will offset the slightly higher price of his proposed solution. So listen to his podcast for a number of reasons. One, listen to one of the leading engineers talk about the evolution of the industry. Listen to the different approaches to sustainable aviation and electrification of the industry. Listen to an informed person's fresh perspective on advanced air mobility and the near-term value of eVTOLs. And lastly, Damon's perspective on his proposed solution for Magpie Aviation. Damon, thanks for offering your intelligent, fresh, and challenging perspectives and for joining us. And to our guests, enjoy our talk with Damon Vander Lind as you innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Damon Vander Lind is the co-founder and CEO of Magpie Aviation, which is enabling long-range flights with truly zero emissions. Damon has 15 years of experience in developing electric aircraft. He founded and managed Kitty Hawk's Heaviside project, a single-seat electric vertical takeoff and landing aircraft, which set the range and speed records prior to 2021. Before this, he was the chief engineer at Makani Power, which he helped to sell to Google in 2012 and managed in Google after the sale. Makani was developing airborne wind turbines capable of generating up to 600 kilowatts, enough to power about 300 homes.
Damon, it's such a pleasure to have you on. Thank you very much for joining us.
It's my pleasure, Luka. I like what you've been doing with the podcast, and it's nice to get on.
Very kind of you. So first question we ask, is there anything that very few in the industry agree with you on?
Yeah, I'd say that there's two things. One is that in the AAM market, we generally expect the best use cases to be slightly longer range than most people. I think there are a lot of folks who are kind of aiming down in the 20, 30 mile range. And we see that, the most utility will probably be longer ranges where the time savings are greater. And two, our take at Magpie has been that we think the pressure for low emissions, at least in a significant number of markets, will increase more rapidly than most people are expecting. And this means it just has to become a larger component of whatever company in the space is trying to do.
Elaborate, please. You're saying that most in the industry don't think that decarbonizing aviation is receiving enough attention?
Yeah, I'd say, well, the way I'd put it is this. The pressure has been to add new utility in large part, but we think there's a lot of market opportunity to allow, for example, markets in Europe to keep doing what they're doing today. So if you look at what the Nordics have done, the short distance flight ban in France, we see a lot of pressure on the industry, a lot of negative pressure, where we think the industry will really have to push just to continue to exist in its current state and really need solutions that deal with the carbon problem they have first.
The essence of your business venture depends on greater focus and sustainability, doesn't it? I mean, at the end of the day, that's your core value.
Yeah, I mean, we're creating an enabling technology, so I'll say that it depends. But when it comes to conventional takeoff and landing aircraft, that is where we add value, is decarbonization. And of course, that being our premise, that is going to be a bigger and bigger focus at an even faster rate than people have been predicting, is of course why we ended up focusing on this technology.
Damon, your first comment about how something that few agree with you on. So you're claiming that the greater value of AAM will come from longer range, and some people disagree with you on that. Is that correct?
Yeah. So I actually, when I was running Heaviside, I started flying to work. So I made a point of trying to go and live the use case, because the general use case that the industry has been chasing has typically been, let's call it 20 to 30 mile flights. And there are places where the short flights are valuable, but those markets are not too extensive. They tend to be places where there are large natural barriers. The Bay is a good example where there is a large natural barrier. And I found flying to work, it was very hard to make it a time savings. So once the novelty wore off, it actually got to be more of a headache than driving in many ways. Like, well, I can't take a call because I have to change transport modes, for example. I love flying, but it was a great example of the cost of time to change modes. The moment you start going 50 or 100 miles, that changes. And all of a sudden, you get a huge time savings over driving. So I generally think that for advanced aerial mobility, for eVTOLs, for that market, we should expect longer range flights, which offer a much greater time savings per dollar spent, to be more important. What I like about that also is it also means that it makes it a lot more accessible. So when you look at a middle-class family trying to fit more into a vacation, that is a use case that's pretty affordable with an eVTOL flight at prices people are expecting. When you look at the daily commute, that becomes tenable only for a much smaller subset of society.
And for your test case, what was your route that was your commute when you were trying that?
I was flying Oakland to Palo Alto. And so I would typically have about a 12-minute flight. I would have bike ride on either side, which I could have cut a little time off from that. And then I had the time to taxi, take off and land, fly the pattern. That transition time, even with a very streamlined pre-flight, that transition time ended up being a pretty big headache. And even, the moment you start using any kind of transportation, say if you have kids, the transition times, we're probably all familiar, becomes even longer. So I saw that those mode transitions were the biggest challenge. And once you get to a longer distance, suddenly, it's worth it.
Damon, in some ways, aren't you kind of undercutting 75% of the eVTOL value proposition with your claim?
I don't think so, actually. I think that these vehicles are incredibly useful. If you ever try to fly 100 miles, you have to end up landing at some small rural airport, and then you have to find transport from that airport to where you're actually trying to go. I think that in that distance range, when you can go straight to where you're trying to go, especially if the location on the far side, if you're going presumably from a city, if the location on the far side is a little more rural, so it's easier to put in a landing site, I think there's huge value. I think that, and you asked me what people might not agree with. I think the thing that is a little contrarian as far as our view here at Magpie goes is just that city to city use case. It's not that it's not going to exist. I just don't think it's going to be as big as many expect. I think that longer range use case is going to be much bigger.
Well, let's rewind the clock a little bit and go back to your early career. How did you end up at Makani? And what can you tell us about the experience there? How did that shape your views on the electrification of aviation?
Yeah. So Makani Power was a company trying to develop tethered, basically kites for wind power. I went there as an intern. I was originally going to go do a PhD at Berkeley building climate models, actually. And, I went there as an intern and found they were working on soft kites. So basically kite surfing kites. And what I dug into with some other some very talented engineers there was actually modeling performance and looking at how to converge what the company was trying to do as a goal with what the company was doing day to day. And this led to a pretty big change. We changed from flying essentially kite surfing kites to generate power to building what are basically tethered gliders with electric motors on them. So they're actually not too different than the technology people are working on today as far as eVTOLs go. So that led to me then being made the chief engineer on the project. We then had a very unfortunate situation in that the CEO at the time, Corin Hardam, who was a good friend and mentor of mine, passed away in the office. And he had done a huge amount to make that company into kind of get the groundwork together and change it to that path we started taking, the tethered electric aircraft. So when he passed away, myself and Alden Woodrow, who later went on to found Ike, we stepped up and kind of took on the challenge of his role. And we actually, I'd say we were more lucky than good in this, but we sold the company to Google and got it into Google X, which I think was a very good home for it. As wind and solar became cheaper and cheaper, it became a narrower and narrower business proposition. And, it became clear over time that it was going to be very challenging to bring to market. I'll actually say my biggest regret with that company was not pivoting it towards floating offshore wind, where we still have not seen the right solutions out there in space. But what I'll add to that is that it was a wonderful introduction to building essentially what the AAM industry is doing today, which is very lightweight structures that have to perform extremely well over long fatigue lives in challenging conditions with lightweight electric propulsion systems that can't fail.
With the experience at Makani of building and trying to commercialize reliable autonomous systems with pretty complex control systems, armed with that experience, how do you look at some of the current efforts in advanced air mobility?
A lot of people who started at Makani have gone into advanced air mobility and done phenomenal things in the space. I think we learned a lot of the challenges earlier that a lot of people are learning now about how hard it is to build redundant systems that are both reliable and low maintenance. I see a lot of good work in the space. I think it's tenable trying to get to the level of reliability you had to get to with Makani for a power generating level of profit is hard. Doing it for passenger transport is very tenable. It's very doable.
Fast forward, you're now at Kitty Hawk. Give us some key learnings, key insights. How has that experience shaped your views on electrifying aviation?
So at Kitty Hawk, I started the Heaviside program there, along with Andy Gessling, co-founder here at Magpie, and a few other folks. And we were looking at the state of play at the time in electric vertical takeoff and landing aircraft. And we thought that it was important to really put a focus on range and sound level. So we really designed the aircraft around that. I would say a really big learning out of that was that, and I still hold this belief, that there are a lot of wonderful professional use cases that can be served by eVTOLs that the industry can focus on in addition to the passenger carrying operations. Just because, those markets are smaller, but they're generally a higher profit margin and they're a little easier to enter. Passenger carry is kind of the pinnacle of aviation development. Bar is higher. It should be higher. Other things, I'd say it was a wonderful opportunity for us to learn to move faster than traditional flight test in many ways by flying uncrewed. And many other companies have done this as well. I think Joby's done a really good job of it. I think Archer is doing it, where you really can change your risk profile and get a lot more learning earlier by getting out there and flying. And it's an important thing for company culture, right? Like you have to, if you don't go learn from the real world, it's much harder to establish ground truth and what the real challenges are. That said, I also think we learned a lot about the value of traditional aviation. I mean, the rules are written in blood, and there's no scenario in which we can ignore the learnings that have been made to date. We simply can, I'd say, kind of augment the processes people have developed to get into flight earlier and to learn more from flight and kind of rely less on assumptions from the get-go. That enabled a lot of what we were doing with the kind of unique heavy-side layout.
What are your thoughts on the contrasting approaches between how to take these new types of air vehicles to market? One being like what Joby and Archer are pursuing, which is building a passenger carrying air vehicle and then operating that initially on fixed routes and probably for quite a number of years, versus bringing smaller aircraft into the market via the general aviation community. On the one hand, we can think about AAM as enabling people to save time on travel routes that they already do today. And on the other hand, we can think about it as enabling people to fly between points that they would not have considered traveling between as feasible previously. What do you think about those, the two different approaches to mature the technology and bring it into the market?
Yeah, I mean, I honestly think they're both valid to pursue. It's kind of a higher risk, higher reward proposition to go straight for passenger. And that's justified, right? Like if you get a higher reward, it's worth taking a slightly higher risk. I also think that we shouldn't expect the first generation of aircraft in this space to be the end of development. And so that gives a lot of value to taking the more general aviation approach, provided you have a good initial customer set that can support you and that, you have the means after that to go develop your second product. I think that's also a pretty viable path. I mean, honestly, I think that a lot of how people use these aircraft, we don't know, right? We're going to get them out there and we're all going to learn. We all have our guesses, but we should be a little bit humble about it and expect that, you get out there in the real world, you have something reasonably versatile and you see what people want. And those who are willing to listen to reality when they reach that phase, they will be successful. And those who are very set on following their preconception of the market demand, I think they'll run into challenges.
What are some of the other ways that your assumptions on the eVTOL market or the eVTOL value prop changed based on your experience at Kitty Hawk?
I mean, honestly, the biggest thing was range, was just getting to doing flights that are long enough that the mode transition is worth it. I think there's a lot of cases where you're flying, you're covering enough distance. It doesn't really make sense to go to a local airport because that adds a lot of time and transfer hassle. So the biggest one would be just that we expect longer flights to be more valuable. The other thing I'll say, a lot of the industry, I'd say, has focused on flying in pristine conditions. It's, of course, much easier to fly in California than to fly in New York, given things like icing and just the general level of inclement weather and, greater level of IFR, for example, over there. So, a big takeaway was we were spending a lot of time trying to just get the basic, VFR vehicle together. One of the reasons we started Magpie is that with our technology here, with our towing system, it's a lot easier to carry IFR reserves, to fit icing equipment to an aircraft, and to build something that can cover the off nominal as well as just the nominal flight. And that was a big part of us deciding to take this on.
So before we start talking about Magpie, just to follow up on your comment about range, based on existing technologies, what do you think is a realistic range for the eVTOLs of the like that we're seeing in testing today, once we account for all of the realities of the world, whether this is environmental, operational, regulatory constraints?
Yeah, I mean, that's a great question. I hate to give a little bit of a cop-out answer, but what I'm going to say is that I think we're still seeing the industry understand how to build these vehicles to be very efficient. I mean, we went out and we set the range record at 150 miles with heavy side, and then, Joby 2 years later came along and bumped it up to 250. And, that's a great step. That's really good for them. And it shows, kind of an evolution in the space. And before us, I think it was like 40 miles. It was much lower. So I think we will probably see initial ranges be quite poor. We'll see them in practical real world experience. We'll see them, with reserves. We'll see them down in the maybe 50 miles being an economic range. And then I think we will see some progression there. But I think that the smart path in the industry will be to take that progression, because you not only need the range, you also need to go into inclement conditions. Will be to take that progression and build out capability. So in the wild, fantastical future where we would like to see the industry go, you use a Magpie system and you end up building a pressurized, icing capable eVTOL, and you can start doing flights that are 200, 300 miles at turboprop cruise speeds. And all of a sudden you're going from something that's, you're trying to fit above cars in range, but below, airport to airport, small airport to small airport, to something that's just incredibly capable and kind of beyond the status quo on all axes. And that would be really cool.
Damon, you're outlining initial capabilities for the eVTOL companies that is at a range that you essentially consider to be unacceptable. And I know you're saying it's going to develop over time, but a lot of these are publicly traded companies. And the investors are pretty confident that once it gets certified and once the infrastructure is in place and the air traffic is in place, that they're going to be able to make a lot of money. I'm kind of hearing from you, you're a little skeptical on that. You think that initial range won't be able to commercialize all that well. You need to get to 1 to 150 to get to the true value. Is that what we're hearing?
Yeah. And I'm a little more of an optimist than that in terms of value. I would say that I don't think that the sweet spot is the short range trips. And like I said, I think there are a lot of markets where, there are markets where you have those short range trips, but, you sort of need to be in special geography. So if you're flying across some between islands where there are no, bridges and your option is a boat, if they're 20 miles apart, that's great. A 20-mile boat ride, especially if it's open ocean, that's not, it's not your first choice if you have to do it all the time. But that's not everywhere. Market potential, once you can hit the range, once you get to that, 100 plus mile range for a given flight, I think the market potential just explodes. So I think for these aircraft to become truly ubiquitous, you really do need that range. And before that, it's fine to enter the market with those shorter ranges. You're just not going to grow to your full potential.
Damon, so you have committed, again, the next chapter of your life to decarbonizing aviation. And I'm sure as you were ideating initially on the direction of Magpie, you looked at the entire design space and analyzed the different designs in terms of conventional, short takeoff, perhaps even sea gliders, different choices as it relates to the propulsion system. So what's your analysis, and you can go to whatever level of detail you'd like.
Yeah.
How do you assess all of these different approaches?
Yeah. And I mean, I can answer this from kind of two perspectives. One is where in the configuration space of aircraft and operations we see there being a lot of value. And one is talking about different propulsion technologies. So maybe I'll start with propulsion technologies because that's really what drove our thinking. In the range of, and I should really say energy storage, but in the range of energy storage and propulsion, we've got basically biofuels, electrofuels, hydrogen, and electric. And I'm very careful to split out biofuels and electrofuels and not just call it SAF because they are very different things. So we looked at all these options, and really our conclusion that there was no slam dunk out there led to us starting Magpie. So I'll kind of run through the list here. On biofuels, there are some great ways to reduce emissions, not eliminate, since they still make contrails and there's still a energy consumption of production. But so there are some great options, but they tend to be very narrow in available volume. If you look at what it would take to power global aviation, it basically takes all the cropland of North America. I don't think we have that much cropland to offer for aviation, honestly. I've talked to people where they say, well, if everyone stops eating meat, right, we can do it. And that'd be very nice, I guess, but I just don't see it happening. It tastes too good. The next on the list. So, okay, biofuels, there's some value there, but they don't scale all the way. They're a good start. Electrofuels. Happy people are working on them just like anything else in the space. They're very inefficient. And so while there's this wonderful benefit that they drop into existing aircraft, the downside is you're talking about efficiencies in the mid to low teens. That means you need, 6-8 times the power on the input that you're getting on the output. Building 6 or 8 times as much, solar or wind it's a noticeable difference, not only in cost, which is pretty obvious, but also just in the impact. These things aren't without their own consequences. You have to put them somewhere. As much as I love wind power, it is, it's a landscape looks nicer without it, right? So, we should only build what we need. So we see that efficiency both making the impact larger and making the cost pretty hard to stomach. And this is the same conclusion that consultancies like Bain reach on both these fronts. Hydrogen, it's a little better on efficiency, but it requires, a bit more aircraft development. So we see it as being sort of sitting somewhere between electrofuels and electric in both range and efficiency and cost. Again, it's good for people to work on these things, but it's not a slam dunk, because I'll just give the example. Like, if you have an 80% renewable grid and you're making hydrogen and electrofuels, you might as well just burn Jet A. So 80% renewable, that's a pretty renewable grid. That's doing quite well. I think we're at like 40% today in California. Well, I guess plus nuclear, so a little bit better. That's going pretty far into the future and getting things pretty dialed and correct for hydrogen or electrofuels to work out right. So again, doesn't say you can't do it. It's just that it's not a slam dunk. So battery electric, the reason that we like it is that it's very efficient and it's already on a phenomenal cost curve. When you look at the cost of batteries over the last 3 decades, it's basically been 10x cost reduction per decade and maybe 50% increase in energy density per decade. So you have to ask yourself, what would happen if the trend of the last 3 decades kept going another decade? It's kind of like previous energy transitions. Petroleum is just on a totally different cost basis than whale oil, right? And so the things you do with it are very different. You don't just like light your home with it, you drive your car with it. And so, same idea as we switch to battery electric, and it gets on its own cost basis far beyond petroleum. We expect moderate increases in battery density, but obviously, with what we're doing, we don't think that, again, if you just project the past into the future, we don't expect there's going to be a magic battery that gets you flying coast to coast. So we see a big need for ways to get range out of electric aircraft.
Do your assumptions change if we, in the next decade or two, experience a breakthrough in carbon-free electricity generation, be it in fusion or some area of existing nuclear? Does that change your assumptions about the viability for electrofuels?
I think you'd need 2 things. I think you would need that electricity price to get very low, and you would need electrolyzers to get a lot cheaper.
Electrofuels are essentially priced based upon the cost of the renewable electricity that goes into them. That's the bulk of the bill of materials.
It's the electricity that goes in, and then it's the fixed cost of the plants to make the hydrogen that you need as an input and to capture the carbon that you need as an input. So if the electricity gets really cheap, that's only one element. If you have, for example, if carbon capture is still quite expensive, your electrofuels are expensive. If hydrogen production is still quite expensive due to electrolyzer price, it's still quite expensive. So you actually need all of those things to get a cheap electrofuel.
Okay, that makes sense. I look at electrofuels with a lot of interest. It's sort of expanding the scope beyond their use in aviation, but thinking of them as a alternative mode of storing electricity, and one that we can use to transport energy in bulk using shipping, et cetera. I mean, we have constraints in how we can move electricity around the world in transmission lines. And I look at electric fuels as having potentially long-term strategic advantages that might sway their development in favor of pursuing these things beyond just the scope of aviation. But I'm still looking for the pathway by which people actually put their shoulder into it and get that done.
Yeah. And, I'm not going to do the normal, startup founder thing of saying we've got it, figure it out, we know the future. We don't. There is potential with electric fuels, but if we look at the trend of the technology today, we would say that it's, there's nothing that shows it's going to get to a low cost in the future, short of some breakthroughs. Those breakthroughs could happen. So totally worth pursuing, people trying to make advances in the field. But if I have to bet, all the beans on electric fuels, I'm not ready to do that just because we are relying on future technological breakthroughs. Obviously, that energy density you bring up is extremely compelling. We have not shown we can reach the cost basis or the scale with that technology yet, and it's at least one, possibly many breakthroughs away from commercial viability.
Damon, you mentioned while in Makani, one of the surprises was that wind and solar got cheaper and cheaper to the point where the value proposition of Makani really started to erode.
Yeah.
If you think about the pursuit of battery electric flight, if any such surprises come up, where are they likely coming from?
Yeah. I mean, I would say we basically, on Makani, we were on the other side of that. We were on the generation side. And so one lesson I took is if you see a trend that, kills your business on the generation side, why don't you hop on the side where that trend makes your business better? And that's exactly what we've done. There's always the chance of disruption. We could see some electro fuels break through that the efficiencies go way up. We could see, the same in a range of fields. But I do think that once you see a technology like battery electric, solar, and wind, you see them hit that cost curve, it is like an unstoppable force. Once you hit that cost progression from scale, it is almost impossible to stop it from continuing in industry. And so it's a very safe thing to bet on.
So let's talk about Magpie. Give us the vision and the concept.
Our general thesis is we see battery electric being phenomenal on maintenance cost, on total operating cost, but not doing great on range. And if we project the past into the future, we don't see that landscape changing, right? We see energy density increases, which matter, showing up, but we don't see the overall landscape changing. We're not going to match Jet A. So we need something to get to the bulk of flights, which is a way to extend range. So we basically just want to do what superchargers do for electric cars. We want to build the supercharger network of the sky. When you're flying, though, if you land, you've just given up all of your advantage. And I'm sure you've had the experience when you're trying to fly cross country, and the moment you land, it's over. You might as well have driven. So for Magpie, we concluded we have to get the energy to the aircraft somehow. How do we do that? Once we come to that conclusion, everything sounds a little out there, to be honest. But the thing we found was that if we aerotow, it's proven technology. We're building on aero refueling. We're building on glider towing. There are actually as many gliders, roughly, built in World War II as P-51s, the iconic fighter. We can basically have a battery-filled tow aircraft, take off, come up, connect and tow you, take you until its battery runs out. New one can come in and take its place. You can fly arbitrarily long distances, as many tows as kind of makes sense to put in there. For example, if I wanted to fly San Francisco to Denver with today's batteries, that's roughly 3 tows. I'm going to go, maybe the first tow is Stockton, Tonopah, second tow is Tonopah, Price, Utah, third tow is Price, Utah, over to one of the Denver area airports. That really changes the landscape. You go from electric aircraft being a short range solution that flies low and slow to it being a long range solution that flies high and fast. And we just think that's transformational. And I'll add, it's not just for conventional takeoff and landing aircraft. That was kind of where we're focused when we started. But we also realize it's a phenomenal advantage for eVTOLs, because if it's hard to build a long range conventional takeoff and landing aircraft, once you put on a lift system and you have to lift the weight of your batteries, it's extra hard. So we offer a huge advantage in that space as well.
A lot to unpack here.
Yeah.
As the saying goes, just because you can build something doesn't necessarily mean that you should. So while this is a very interesting technical challenge, what's the impact on cost and operational complexity of it? Let's unpack this a little bit more, and perhaps through a detailed view of the ConOps. If you don't mind, let's start from takeoff to landing, take pauses at every major phase of that flight, and then discuss all of the challenges associated with it.
Yeah, my apologies, Luke. And I'll say we deal with this every day, so it's easy for us to start thinking it's normal. And then, we talk to people who haven't been living and breathing it, and we forget how it's a little different, and take some adjustment. Okay, so let's talk through the ConOps. Let's say we want to do this flight San Francisco to Denver, and we'll talk through it, kind of step by step. You take off out of San Francisco. You're going to fly to about 4,000, 5,000 feet, and you're going to connect on tow to an aircraft that took off, battery electric tow aircraft that took off out of, one of the surrounding airports that is not very busy. It could be out of, Stockton's a great example. You then get towed up to cruise altitude. And cruise altitude is not that different than what you do with a jet. So you could be anywhere from, 25 to 35 with today's batteries. You on one tow with today's batteries, because that tow aircraft, it's all battery, right? It's basically a battery with wings and a cockpit. You get about 300 miles. So by that time, you're reaching around Tonopah, Nevada, a place known for its ample solar power. So your tow plane disconnects, it goes down, it lands there. A new tow plane comes up and it takes over and keeps towing you. And it puts in another, roughly 300 miles and gets to about Price, Utah, another place known for ample solar power. And then, you repeat, and the final tow plane takes you to Denver. Now, the downside of this, obviously, you bring up economics, is that we just use 4 aircraft to do one flight. That sounds terrible, right? And that was our initial reaction. We actually we contracted aviation economics in London to study this. And the surprising conclusion for us was, even though you're using 4 aircraft in the flight, because those first tow aircraft can get redeployed, can go start serving some other flight, and because they buy you such an advantage on fuel and engine maintenance costs, it actually works out where it's not, you end up with roughly 2 to 2.5 times as many aircraft in the network as you would have otherwise. But because of the fuel savings, it's only marginally more expensive. And this is compared to, for example, with SAF spending 2, 3, 4 times as much on the fuel. So we're actually very happy to see it work out as only being a marginal cost increase.
Are both of those aircraft Magpie aircraft?
We're basically considering 2 models. One is where we provide the tow, and one is where we just sell the tow systems. And we have found that for different potential operators, different models make sense, and we really need to do both. We find that the tow aircraft, you get a major benefit for it being a tow specific or especially, battery electric specific design. But one of the phenomenal things with what we're doing is that the passenger aircraft conversions are actually great, because it's basically doing what it was supposed to do before. You're not changing the operating point to the same degree that you are for the tow aircraft. And so we see the future as being Magpie design tow aircraft. We actually hired Neil Wilford, who designed the Sky Courier, to design the specific tow aircraft, and generally conversions of things that exist for the payload. And this works just fine whether you're talking about a King Air, an ATR 72, or a 737. Obviously, on different timescales.
What were your pilot cost assumptions when you did the study that said that it was below what you thought it would cost? What were the cost of the pilots, and where were the pilots?
I'd have to go look at the specific pilot costs we use, but we generally we did an average of pilot costs from the study we did with aviation economics was based around the ATR 72. We did an average of pilot costs across 4 or 5 different ATR 72 operators. We did an average of fuel costs over a similar number of operators, and we did an average of maintenance costs as well. So we tried to use as much as possible industry average values. I can get back to you after the recording and get you the pilot costs we've got in there. No assumption of autonomy. Obviously, autonomy is an incredible tailwind, and we see it as it's a game changer for us. But we wanted to make sure our technology doesn't rely on it to function. And that's a big reason why our flight tests to date have all been human piloted.
With this concept of operations, to move, a load of passengers, you're going to have 3 or 4 times more aircraft operations, takeoffs and landings.
Yeah.
Did you look at the impact this has on the national airspace system, and do you have a feel for where this will work, where the airspace system can accept these additional operations? Will it work on the East Coast, or is it more the Western states? How do you look at that?
Yeah, that's a great question. We've actually, the work we've done on this, we've discussed it a fair bit with Eurocontrol. And I think that Eurocontrol is a great example because Europe has some of the busiest, most congested airspace. And I was actually surprised by their response, which was, you think this is bad, you should have seen, you should see what very light jets do to us. So it's a challenge, but it's one that we find the controlling agencies are interested to take on because of the importance of decarbonizing. The other thing I'll add is it only roughly doubles the number of aircraft in the air, and it's not going to happen overnight. We don't expect the whole industry to decarbonize. An airline has a 30, 40-year life. People aren't going to go sell them all today and replace them. So over the time of deployment, we only see it as roughly a order of magnitude 2-3% additional growth rate year over year. And that's a lot more manageable to think about.
What other cost categories have you considered in the economics model? You mentioned that greater number of aircraft operating is offset by the fuel savings. What about things such as pilot cost and additional maintenance and additional cost in scheduling and operating the network, et cetera, et cetera? How does that all pencil out?
Yeah, so we basically try to account for every cost category. And this was a big part of engaging outside consultancies to help us understand the cost basis, because it's very easy to focus in too much on one or two categories. But you have to worry about the non-engine maintenance, the engine maintenance, and I put those separately because battery electric should help on engine maintenance, but not on airframe, right? And we have the pilots, we have G&A. We generally don't assume that, ticketing or passenger experience or anything requires additional costs. But, we assume, for example, when you have more pilots, the overhead costs around pilots go up as well, as you should expect. So, we try as much as possible to get every category that airlines are themselves aware of and make a rational accounting of it. And I think this is part of where we don't come out saying we're cheaper. We come out saying that we cost a little bit more, but it's not as much as, SAF or hydrogen, right? And I just think that's a much more realistic view for the industry overall, kind of informed by these economic studies we've done.
So you're saying that the industry will be willing to pay more for a sustainable solution?
Yeah. And to give you an example, if you...
Yeah, how realistic is this?
Well, companies today are actually, you can't buy because it's all basically booked up. And the price is quite high. So we know there's demand. So we see, in France, we see in the Nordics, we see what's happening. We see, Heathrow offering to cut, to remove their on electric operators. We see some really good progress. I wouldn't say the industry is there all the way yet, obviously, but that's the trend we see. And obviously other markets, it's not going to be the case. They're still going to be very much driven by cost and not in any way driven by emissions. But our take is that you fast forward over the next 30 years and it's just going to be dominoes falling towards emissions being, prominent aspect of what every airline has to worry about.
Can you tell us a little bit about the technology involved in executing an autonomous rendezvous with a tow plane?
What we've found that's really quite interesting is that we can come up with a very safe, reliable way to rendezvous and reconnect, where the safety case is almost completely informed by the pilots and not by technology. and where the critical systems are mostly mechanical. And that's just much easier to certify. So with that, we were able to reach flight test very quickly. So I'll kind of run you through what it looks like to make a connection. So first, you get on the same flight path, you do a rendezvous. We actually draw on what aero refueling tankers do to construct some of our initial rendezvous, things like timed turn to join flight paths, using a different rejoin altitude, and then converging when you need to do the turn to course, the final turn to course. But once you get in position, what you do is you get 50, 100 feet behind what we call the active hook. And that is this device on the end of the tether that is extremely agile and places the tether in the right place to make a connection. You get back there, and then you turn on tracking. Turning on tracking tells that active hook to go fly basically plus or minus a centimeter in front of the probe on the front of your aircraft. So then at that point, all you're doing is managing closure speed. And so you just bump up a couple knots, you go and you bump the active hook, and now you're on tow. And that's basically it. Some of the cool things about it, we actually, we don't rely on the smarts of the device for the basic safety case, but we also get some advantages out of it. So for example, we have keep out zones where even if you go and try to hit the hook, we have it so the hook has keep out zones and will actively try to avoid interfering with the aircraft. We have layers of safety to make sure that it's possible to go in and do this operation. And the agility of the hook is super valuable, I'll add, just because, you can make it work in extreme conditions because of that.
And how does the active end of the rope find the aircraft? What are the technologies involved in active tracking?
We use a range of sensor technologies. So we use vision, GPS, and what I'll call kind of relative radio positioning. Nice thing about having multiple sensor technologies is you get a sense of when one is inaccurate or when there's some issue with one. So it's very nice. The result of all of these, when you fuse them together with a good inertial measurement unit, is a very precise estimate. And that's what has allowed us so far in flight test. All of our connections have been within about a centimeter of each other in terms of relative positioning of the hook. We've just drawn one little dot inside of the active hook where we make first contact every time.
Damon, what are the implications on pilot training? Will they have to go through some retraining type certification?
Yeah, we see it actually as a pretty nice fit for going on a Part 135 certificate, obviously onto the 121 down the road, because it is a unique operation. So in the same way where if there's a 135 operator that's doing helicopter logging, you want to have recurrent training where you cover all of the things around helicopter logging. For us, it's just an operation that goes with the aircraft that should sit with the operator. We see that as a pretty good fit. The regulations have been written around handling new operations in the past. We don't see any reason to break that.
And what are the regulations around flying in formation on an IFR flight plan for commercial revenues?
Yeah.
And how does that differ regionally?
Yeah, no, that's a great question. So, so far as we can tell, it's really not challenging. The rendezvous is not challenging. The getting on connection is not challenging. We're actually cleared to fly anywhere in the US right now. And we're pretty much cleared to do that off the bat. Obviously not overpopulated areas as it's, test aircraft. But I think you're right to bring up exactly where the challenge starts to arise, which is when you get to IFR commercial operation. The procedures actually exist, but they're military procedures. So air traffic controllers are all familiar with what are called MARSA procedures, which are for rejoining and operation of aero refueling. We just need to change that M in MARSA from military to Magpie for us to be able to operate. That is a rule change, but we decided it was an acceptable one because it is a copy of existing procedures. And the thing we're worried about is trying to introduce procedures that have no precedent, right? We want to do things where we have some institutional knowledge to build on. So we that is probably our largest lift on the FAA front, but we see it as a worthwhile one.
And so have you had early discussions with either the FAA or EASA or other aviation regulatory bodies? What feedback did you get from them?
Yeah, absolutely. I mean, my favorite quote so far from our program manager in CECI at the FAA was, I hope you're not offended, but this doesn't seem that hard, which is, music to our ears. Obviously, nothing new in aviation is easy. There are challenges to get through. What I'll say is we set out to work with the FAA from day one. And we were, I want to say within the first month, we were, CCI program of record and starting to work with our counterparts on the government side to find the major issues with what we're doing. We did that with the heavy side program. I would say a lot of companies are afraid of interacting with the FAA, and there's a huge knowledge base there. I think it's very smart for companies to engage early.
I mean, at the end of the day, what you need to have happen is that the increased value of the sustainable solution offsets some costs and potentially some risks, and potentially rather significant risk. I mean, what happens if it doesn't hook, for example? What happens if it doesn't release? Well, how do you make up for, again, where sustainability is the key value? And and a lot of the airlines, for example, have a plan for, net zero by 30, 40, 50. But for that added value, what's the potential risk involved in this completely new procedure? I could see where from a certification standpoint may not be as much of an issue, but what are the greater risks, and what could go wrong, and how do you mitigate for those?
Yeah, no, I mean, that's a great question. I think it's really two questions. One is, how do you manage the risks of doing this in flight? We're doing a lot of what aero refueling has already been doing for more than half a century, and what gliders have been doing for, basically the whole history of aviation. But at the same time, it's new in passenger ops, right? So how do you manage the risks? Basically, we just try to find the simplest way to mitigate each of those risks without relying on a lot of technology. So just to take that example, what if you don't catch your toe? This is why we have been working with hybrid aircraft manufacturers and retrofitters, because we see liquid fuel reserves are always easier to carry. And for the passenger aircraft, carry liquid fuel reserves. If you miss a toe, burn some gas. It has zero impact on your economics if you do that 1% of the time. But if you can't do that, then you have a lot of unhappy passengers. And hitting 99% shouldn't be too bad in this space. What if you can't release? Well, we have multiple releases, right? So we have 3 ways to release the rope, and you got to have them all fail. And so it's almost like asking what happens if the wing falls off, or what happens if an engine fails. It's possible. What you need to do always is have enough redundancy that as far as, statistically, it never happens, right? And that's been our approach. Sorry, your second question was, how do you justify the, kind of the added complexity? And, any play in aviation has to be a long one. We have a lot of really awesome market opportunities that are shorter term on the way. So for instance, with eVTOLs, our take is we're basically the most viable, possibly only way to serve really long distance flights in that sweet spot of range. And, we see that as just a huge value add in that industry. We also have a lot of value, for example, in aero refueling. We're building extremely accurate reconnection devices. There's things we can do there. And, this is why we're working with the Air Force is the ability to connect A to B in air has a lot of exciting applications for them. Tied to that, we do see this trend where, emissions are getting to be higher and higher on the list. And we're seeing enough markets where it's going to be very hard for operators to continue operating without a solution. We've been at some industry conferences. I'll give the example of European Regional Airlines Association that we're a member of. And, what's the topic? It's basically 90%. What are they doing on emissions? Because that is the existential threat to the business.
So, Damon, with a view to the regulatory path for this ConOps, let's drill down a little more on feedback from prospective customers or partners, and talk about the first instantiation of this technology that you would commercialize.
Let's talk first instance. A really nice route, and there are kind of equivalents in Europe, but I'm guessing that a larger audience is over here. So I'm going to pick the California route, is just SF-LA. And that's a single toe. For a space analogy, that's your 2-stage rocket right there. You can take off from any of the Bay Area airports. You pick up your toe out of Hollister, nice airport, very business friendly, easy to put in charging. And you can then take that tow down to Lancaster. Again, nice airport, ample solar power, gets you really close to right on the edge of the busy airspace for LA. You then go and you land in there. By the tow landing earlier, you actually can get it on charge sooner as well. So for an electric aircraft, with today's technology, you would be hard pressed to make that route single stage, might even be impossible. But with the tow, you suddenly added a ton of range and you can start making that route. And what's exciting is you're also keeping that payload aircraft, the passenger one, operating at a higher cadence because its turn time is reduced. It's not sitting there charging as long between flights. So that's a really nice initial route. We can do that in part 23. It's kind of neat. You can connect with that. If you wanted to do direct electric, you have to put in charging infrastructure everywhere. With this, the bulk of your energy is coming out of these two tow ports, and that's where your infrastructure costs are. So you put the infrastructure in once, and you're suddenly serving a cluster of 15 airports in the south and 15 airports in the north. And so you get a lot more bang for your buck. And second part, let me say, you asked about customer feedback. We basically get two categories of customer feedback. We get, this is very refreshing. You're actually trying to solve the real problem. I think we get this because airlines, they sort of worry about the marketing side and they worry about the long-term regulatory side. And on the long-term regulatory side, I think we do a very good job of dropping total emissions from the system. We're just in a different league than other solutions, I think. And so that's very appealing for folks who've been working in the industry for a while and kind of seeing the set of steps that are being done and also how far they get you and how far they don't get you. And then the other thing we get, obviously, is this is insane. You're going to tie two aircraft together in the sky. And what I like about the second one is that we have found a very good antidote to that is just going and doing it. And that's what we're doing.
What about things like pilot shortage, organizing, orchestrating networks? Airlines, it appears, have a lot of challenges as is trying to match aircraft and crew and managing any disruptions that come up, and that do come up.
Yeah.
Now you're introducing twice as many aircraft, perhaps even more in certain situations.
Well, that's one that's definitely come up, but I'd say most airlines we've spoken with, they realize that this supply and demand problem with pilot shortages, it's one that it's time-based. So the reason we have a pilot shortage now is we had a lot of incentivized retirements during COVID. It was smart for each individual airline to do this, but it left the industry in a state where there were not enough pilots when the demand came back. And now we see, greater training rates. So, these things do equilibrate over time, but it doesn't happen instantly because you can't train a pilot instantly. So again, our take is that this isn't going to roll out overnight. The transition time for a new technology in commercial aviation is about 30 years. And on that time scale, you can match supply and demand.
So on this initial route, let's call it San Francisco to LA, what's a passenger expected to pay for that ticket? And how's that compared to commercial travel?
We think we can deliver that at a business class ticket price, or another good example similar to that is a Surfair price. That should make it very compelling for companies that are currently spending money on things like SAF to say, well, I can buy the SAF, I can go and actually get the emissions instead of bringing it down 30%, 40% total emissions, I can bring it down to 0%. That sounds nice. So we see that as a pretty compelling case.
Damon, when you go to talk to the airlines and to get their feedback on this capability, you talked about the pilot availability. Mm-hmm. Who do you talk to at the airlines to get their impressions of this new capability?
I'm a big believer that everyone out there, they sort of have their own contribution, their own view. And so it's really important not just to talk to the sustainability managers at a company. Of course, they're very important to speak with, but also speak to chief pilots, speak with CEOs, speak with board members, speak with line pilots. So we really
have you talked to CEOs or board members of airlines?
We have
on your capability. What's been their feedback? Where have they been most positive and most constructive?
Well, I think that what we just covered is actually a pretty good synopsis, which is the complexity people don't like, right, and they shouldn't. But the ability to have just a step increase in emission reductions or being a totally different class as far as emissions reductions go is very compelling. And the idea that we're not kind of relying on a breakthrough, we're building this out of pieces that exist today. I'd say by and large, it kind of mirrors what we just discussed.
So Damon, fast forward 5-10 years, where does the industry look like? Because your technology, you're looking at least 5 years out, right, before it's really deployed. But what has to happen in the industry in the next 5 to 10 years for it to be optimal to be able to create that strong business case of yours from what we have not already talked about?
Our expectation is that electric aircraft will prove to be, big winners as far as total operating cost and maintenance go, but that the range will be deficient. So, in 5 years, we expect we'll start to see operators out there on short distance routes, but that they'll be itching to go further because that's where the bulk of the market is. And that's kind of ideal for us because that's what we solve. The other thing I'll add is I think we'll get the first generation of electric aircraft out there and operating. And I think there'll be a lot to do still. We see this with every new technology. There'll be a lot to do to go from that to what's really good in that space. So we shouldn't expect that we get to that stage and the innovation stops or something like that. We should see that as, that first step, that almost is just your ticket to even play, right? That's the first stepping stone. We don't know all of the use cases people will find for this new class of vehicles that we see out there, these new classes of vehicles, I'll say. And so we should expect a lot of learning in 5 to 10 years, learning from the market to go and really focus in on where we see the greatest traction.
You've been an entrepreneur at the intersection of technology and flight for quite some time. What advice would you give to people starting a business or thinking about starting a business in aviation?
I would say figure out what you think is kind of a value add in this space that's going to be there for a while and focus on that. In investing, there do tend to be some fads and some bubbles. And so if you can make that good long-term choice, it will probably pay out. You have to be willing to put the time and effort in. Beyond that, I would say, which is almost feels opposite, but I would say make sure there are really compelling initial markets for your products that you can very realistically reach. So for us, that tends to be things like air refueling. Hey, if I can save 10, 20 minutes of tanker time, flight time every flight, that's great. I'm super happy about that. That's saving a lot of gas, So things like that make for, great first steps. Because some companies will be successful out there with shooting for the moon. Just to, kind of call out Joby, super impressive how they've gone straight to this incredible product that they're, making huge strides in certifying right now. But that's the minority of companies. So statistically, you should plan on your company being moderately successful and make sure that whatever strategy you pick is going to be good if you're moderately successful. And that sets the groundwork to be, largely successful later.
That's a great answer. Let's put Magpie aside for a second. And you were going to invest your own money into any advanced air mobility capability today.
Yeah.
And you needed a return within 3 to 5 years.
Yeah. I would invest in things that have dual application where you can serve, civilian market, private market, military market. I would invest in things that have historically seen reasonable timelines to market. Sorry, this is a general answer. And I would invest in things that are primarily enabling capabilities more so than new aircraft concepts.
Any companies jump to mind?
I think there's a lot to be done in autonomy. So without kind of picking on one autonomy company or another, I do think that there's very exciting things to happen in that space. I think in the world of sensors, reliable communications, kind of the less sexy part of new aviation. I think there's a lot to do there. Air traffic management, there's a lot to do there. And then I think, in the small to medium drone space, there's quite a bit to do. More on the sustainability side, there are some pretty good opportunities to start working around the edges of emissions. So I would love to see more work done, for example, with zero engine taxi, just to bring up one.
Right.
Oh, and I just think that the pull for that kind of technology is, we're kind of in that phase where it's only going to go up in especially in some key markets.
Yeah, a lot can be done with zero engine taxi today. And given your experience, Kitty Elk, I have to ask, if you were a betting man, when will we see fully autonomous aircraft at scale?
Yeah, I mean, I would say that the
Give me a
F-35
year.
is fully autonomous and the military uses it today.
How about on the commercial side?
Yeah, and there, I think our expectation should be that it's a stepping stone and it will start in more rural areas. We see this with some of the drone operators today getting 135 operating certificates. So I actually think in the next 5 years, we will probably see some autonomous operations somewhere start to come into play. I would be surprised, though, if we see it, kind of over our cities in less than 10 years.
So how would you wrap up the podcast, Damon?
I would say the things that I really want to emphasize, one is that total emissions will only become more important. And so if you are working in the sustainable aviation space, making a bet towards, realistic total emissions is going to be a good long-term bet. And the second point I'd make is just that we should probably expect the contours of the market not to change that much. People will want to fly longer distances just like they do today. And then the third point I'd emphasize is that, and this is really reiterating our thesis to a large extent, the third point I'd make is that there is a lot of potential with battery electric in terms of cost. And it's going to be very exciting to see, once we get those aircraft out in the field, exciting to see where operators take them and what niches they find where they're really valuable.
I think that's a great way to wrap up the podcast. Really enjoyed the discussion. So thank you very much again for being our guest.
Yeah, it's my pleasure, and really wonderful discussion, and love to keep seeing topics that you are covering in the future.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.